Let's talk about generator functions. Generator functions look like regular functions. However, inside their body, they have yield. Yield is both a statement and an expression. As a statement, you can say yield and then some expression. You can also just say yield with no expression. This is also an expression that can be embedded in other expressions and statements. We'll talk about that when we cover coroutines. This is very exciting stuff. Let's write a Fibonacci generator. I like to call my generators with the gen at the end to remind myself that these are generators. These are not functions that return values. So the Fibonacci generator doesn't require any arguments. The first item in the sequence is 0, and the second item is 1. So we'll yield that and yield that. We'll remember the previous values and the previous values just like before, and we'll infinitely loop, calculating the new result each time. Moving the previous results down. And then yielding that result. Note that this function never returns. The way you use generators is you first call the generator. What this does is it starts the function and remembers the frame referring to it. If you've passed in parameters, it will assign those variables. In this case, I'm going to use this sticky note to represent what's happening. So let's put that up here. Hopefully you can see that. So it reserves a spot for prev, and result, because this function contains assigned statements to those values. Note that this function does nothing. It's just remembering a pointer to the beginning. I'm going to call it the PC at the start. Okay? A generator is an iterator, so we can call next on G. When you call next on a generator, it continues from where the program counter was pointing. In this case, the beginning. When it hits a yield statement, it returns that as the next value. In this case, the first statement is yield 0. So this one yields 0. When we call next again, it remembered where it was pointing. So let's put line 2 now, because it remembers where it is. And so when we call the next, it continues execution there. In this case, it says yield 1, so next will yield 1. And the program counter is now pointing at line 3. When we call next again, it continues execution from line 3. So prev is 0, previous is 1, while true, result equals prev plus prev, so it's 1. Prev equals prev, that's now 1, and previous equals the result, that stays at 1. And then we yield the result, in this case 1. And we remember the program counter, which would be the while. Okay? So yielding 1, if we were to call it again, we continue with the while statement. Result is prev plus prev, so now that becomes 2. Previous is the previous, it stays at 1. Previous is equal to the result, that becomes 2. And then we yield that result, which is 2. And if we call it again, it continues. Result equals prev plus prev, so that becomes 3. Prev equals prev, that becomes 2. Previous equals the result, that becomes 3. And then we yield the result. And if we call it again, result is prev plus prev, so it becomes 5. Prev equals prev, that becomes 3. Previous equals the result, that becomes 5, and then we yield that result. You can see how this function works, and it will indeed yield an infinite sequence of Fibonacci numbers. In this example, we're going to interleave 2 sequences. This is going to be a generator. The first thing we'll do is we're going to convert these to iterators if they're not already. Next, we're going to go through an infinite loop where we yield items from each one. If one of the sequences were to be exhausted, it would raise the stop iteration, which is exactly what we want the generator to do when it runs out of items. Let's go ahead and give this a spin. So I is equal to interleave. Let's see, let's use the range up to 2, and let's use range starting at 10 and going to, let's say, 15. Okay. When we call next I the first time, this is the first time next has been called on this generator, and so we're going to start from the top. A becomes the iterator, A. Let's go ahead and keep a sticky note here to keep track of the variable context for this particular generator call. So A is now the iter for A. Then the next statement is B equals iter B. Okay. And then it enters this while loop. The first thing it does is yields the next value of A. What's the next value of A? Well, that would be 0. When we call next again, it continues from where it left off, yielding the next value of B. Well, that would be 10. If we call next again, it continues, restarting the while loop because true is always true, yields the next value of A, which is going to be 1. And then if we call it again, it will yield the next value of B, which will be 11. Then when we call next again, we'll go back to the top of this while loop, yielding the next value of A. Well, the next value of A would be the number 2, but that's the termination of the sequence, so it actually raises a stop iteration. At this point, the generator is done. The yield statement can also handle this syntax: yield from some expression. And when expression is an iterable or an iterator or a generator or anything like that, it will yield all of the results from this expression before continuing the program. This is a great way to embed generators in each other. Let's give an example here. We're going to join two functions, two sequences together, and we'll call it the join gen. It takes 2 parameters, and all it will do is yield from A and then yield from B. Let's go ahead and give this a spin. So let's say J is equal to join gen range 2 and range 3. Okay. So when we call join, it's going to create a new context, a local context, local scope, where A is going to be assigned to range 2 and B is assigned to range 3. When we call next on J, it will begin execution from the top, yielding from A, which means it's going to start yielding values from this sequence. So the first value is 1. When we call next J again, it doesn't continue with execution of this program. It's going to continue until it exhausts A. So the next value is 1. When we call next J again, we note that 2 would be outside of the range. And so it has exhausted this sequence. And so it continues execution with the next statement, in which case it's yielding from B. And so the first item from B is 0. Next call to J should yield the next value from that sequence because we must exhaust it first. And next J will return 2. And when we call next J again, well, 3 would be outside of the sequence range. And so it's not going to yield anything. In this case, it's finished its execution, so it raises stop iteration. I have a whole lot of examples to share with you to give you some ideas on what you can do with this. Let's write a repeater. This repeater generator is just going to repeat the same value again and again. It's pretty easy to write. Use an infinite loop and just yield that value. As you can see, this will just yield the same value again and again. It will never cease. Let's write a flipper. It flips between two values A and B. In an infinite loop, it will yield A and then yield B over and over again. How about a counter? This will count up from 0 to infinity. So we start at 0, and then in an infinite loop, we yield that value and increment it. Maybe we want to cycle through values over and over again. Let's have some kind of maximum we want to go up to. So like the counter, we start at 0. We have an infinite loop. We yield that value. We increment it. We say if n is greater than or equal to maximum, we start over again at 0. At this point, I want to refer you to the itertools module. You can find it in the Python documentation. There's a ton of useful iterators and generators that they've given you. So 90% chance you won't have to reinvent the wheel here. Hey guys, I hope you enjoyed this lecture. If you have any questions, join me on Discord. If you want to see more videos like this, be sure to support me on Patreon. Take care and bye-bye. Thank you for watching this video on the theory of Python by Real Physics. Be sure to subscribe and ring the bell, like and share this video. You can find me on Discord or support me on Patreon. Links are in the description below. Thank you so much. Have a great day. Bye-bye.